Okay, welcome back to another lesson. In this lesson, we are going to look at a question in linear programming that was tested in September 2021. And this was question number 2B. The question reads, Zachem Limited produces two products, namely Alcon and Xenon. The products pass through three departments, namely assembly, finishing, and packaging. There is a maximum of 200 hours in each of the assembly and finishing departments. In addition, a maximum of 400 hours of packaging are available for packing Alcon and Xenon. The table below shows a number of hours required per unit of each product. Then you are told that in each of the Alcon and Xenon gives a profit contribution of 3,000 and 2,000 respectively. You are required to formulate a linear programming model to solve the above problem. Now, here, you don't know how many units of Alcon and Xenon are being produced. So we begin by saying, let the units of Xenon, let the units of the first one is Alcon, produce and sold, produce and sold the X. That's the first step. Then you also say, let the units of Xenon produce and sold be Y. Now, remember, from the statement here, there is a maximum of 200 hours for assembly and finishing departments. And here you have been given that in assembling, you require 2 hours for Alcon and 3 hours for Xenon for each unit of Alcon. Therefore, what should we do? We come here and formulate our inequalities. The maximum hours for assembling is 200. The maximum hours for finishing is 200. And the maximum hours for packaging has been given here is 400. So, our inequalities will be, the first one is 2x plus 3y is less than or equals to 200. Where am I getting 2x? Here, I'm saying if I take 2 times the number of units of Alcon, which is x, plus 3 times the number of Xenon, which is y, I should get less or equals to 200. You do the same for the other, that is 4x plus 2y is less or equals to 200. Where am I getting this? From the table. 4x plus 2y is less or equals to 100. And finally, we also have 5x plus 3y is less or equals to 400. From this table here, 5x plus 3y is less or equals to 400. You have been given 400 here. Take note that x and y cannot be negative. X and y should be greater or equals to 0 because you're talking of the number of units. And the objective function is given as z is equals to 3,000 x plus 2,000 y, because you have the contribution here. You're told that Alcon is 3,000, Xenon is 2,000 per unit. These are the contribution per unit. So that is how you are to get your full marks on formulating linear programming model. 2, you are told that using simplex method, solve the linear programming model formulated in B1 above, and you have a total of 14 marks. Here, you have to be very keen on your working. You have to be very keen on your working because we shall have a table which we are going to call initial simplex table. We shall have a table here called initial simplex table. But before that, let's convert inequalities to equation. Let's first convert inequalities into. How do we convert inequalities into equation? We do this by introducing slack variables. Now, we remember here we are saying that 2x plus 3y is less or equals to 200. It means it can be 2x plus 3y is 190. So where is the 10 going to be captured in this inequality? If you find that 2x plus 3y is 190, but you are saying it's less or equals to 2000. So we need to factor in that variability in the fact that you may get the values here being less than 200. So, and that's why we have to introduce some slack variables. Now, the first, we can say this, let S1 be slack variable. Let S1 be slack variable for assembly. Let S1 be slack variable for assembly. We also say that let S2 be slack variable for finishing. And finally, let S3 be slack variable for packaging. Now, having identified these slack variables, we shall now be in a position to get our inequalities into equation. Therefore, we start with objective function. Our objective function Z will be 3000x plus 2000y plus 0s1 plus 0s2 plus 0s3. I'm introducing these slack variables, and I'm saying 0 here because Z, the profit is obtained by actual values which you get here. So there is no there will be a gap for you to get the profit. So whatever values of x and y are going to be obtained, they are going to give you the profit. That's why the slack variables here, they are 0. Now, then the other equations, we shall have this Z objective function. It is subject to the following equation. Subject to the first one, we said 2x plus 3y is less or equals to 300. And I've said from the statement above, S1 will be a slack variable here. So if I bring a slack variable, it means I should get is equals to 200, meaning that I can introduce an is equal sign here. Because any variability is factored in by the slack variable. We move on. The next one will be 4x plus 2y plus s2 is equals to 200. And we also have 5x plus 3y plus s3 is equals to 400. This one is for assembling. This one is for finishing. And this one is for packaging. I've introduced these slack variables and I had mentioned them in this statement here. Now, remember, among all these slack variables, we don't expect any to be 0. So we are saying x, y, s1, s2, s3, they all need to be greater or equals to 0. Now, we need to come up with our initial simplex table. Here, we need to come up with our initial simplex table. Initial simplex table. Initial simplex table. Now, this is the format of this table. This is how the table is supposed to be. This is how the table is supposed to be. In the first column, we are going to have a contribution, abbreviated C. That is our first column. Then we shall have the second column called basis. The third column is going to be occupied by X. The fourth column is going to be occupied by Y. Then we shall have the slack variable S1, slack variable S2, slack variable S3. Then we shall have BI, or value. You can just write the value to make it clear. BI, or the value. And finally, we have the ratio. Now, the basis here, we are going to put in our slack variables. Here we have S1, S2, S3. Those are our slack variable. And I introduce CJ, I introduce ZJ, and finally I introduce DJ. Now, the bases are the one along this column. Then contribution, here we are talking about the coefficient. What is the coefficient of S1 in our the S1 in our objective function? In our objective function, S1 have coefficient of 0, 0, 0. So, initial simplex table, we shall find this one being 0, this being 0, and this being 0. Now, where we have S1 here, we look at the coefficient of X and Y. The coefficient of X here is 2. The coefficient of Y here is 3. Then S1 here is 1. And we don't have S2. We don't have S3. And the value given here is 200. Now, we go to S2. S2, X here is 4. Y here is 2. I'm looking at the second equation. There is no S1 in S2. S2 is 1, this is 0, and this is 200. S3, we have the coefficient of X is 5. The coefficient of Y is 3. There is no S1, there is no S2. S3 here is, S3 is 1, and the value is 400. Cj are the coefficient of the objective function, and they're going to remain the same throughout, which is 3000, 2000, 0, 0, 0, and 0. Zj, how do we come up with Zj? In our initial simplex table, Zj will be 0. What we normally do is, you take the contribution multiplied by the values in each column. In this case, since the contribution is 0, in our initial simplex table, our Zj is 0. Our this is 0, 0, 0, 0, 0. DJ is supposed to be, I want you to take note of this. Let me draw this here and emphasize my point. If you want to find DJ, DJ is supposed to be Cj minus Zj. So we take 3000 minus 0, you find 3000. 2000 minus 0, you find 2000. Then this 0 minus 0, 0, 0, 0. Now, this is what we call initial simplex table. This is what we call initial simplex table. The next thing you are going to do here is to test optimality. The table here is not optimal. The table is not optimal. The table is not optimal since some DJs are greater than 0, are greater than 0. Now, we have now to move and create another table, but there will be some computations that will be necessary before we move on. Where are these DJs? Let me just emphasize on this point. First, we are saying that the table is not optimal since some DJs are greater than 0. Here, I've said DJ is Cj minus Zj. This one, we have 3000, 2000, then we have 0, 0, 0, 0. Since we have 3000, 2000, these values are not 0. We should be left with 0 or negative along the j, so that we see that the table is optimal. Having found this value which is greater than 0, we look at the greatest or the highest value. In this case, I will have 3000 being the highest value. Now, this one, we call this one key column. We call this one key column. Now, on top here, on top of the key column, where we have x, this one we call this one outgoing. This one we call this one outgoing variable. Outgoing variable. This one we call this one outgoing variable. This one, in fact, this one should be this one is the one which is supposed to come inside here. So this one will be incoming variable. Incoming variable. This one is supposed, because we have identified a variable that is supposed to be substituted within our slack variables. That's why I'm calling this one incoming variables. Now, the second thing, having identified the key column and you have identified the incoming variable, we need to divide the values with the coefficients in the key column. Like in this case, I will take 2000, not 2000, 200. 200 divided by 2 to give me 100. This is 200 divided by 4 to give me 50. Then here I'm having 400 divided by 5 to give me 80. I hope you have noticed what I've done. The first step, I've identified the key column. Then I've identified the incoming variable. I've taken the coefficients of the key column. I divided the value with those coefficients. Then the answer you get here, you choose the list. Choose the list. Here the list is 50. This one is called key row. Key row. Key row. Then we shall now look at a point where the key row and the key column intersect. Here we shall have this number 4 is called key element. A point where the key row and the key column intersect, number 4 is called key element. Now, having identified those items, I'm now in a position to draw the second simplex table. We come here and draw a second simplex table. A second simplex table. A second simplex table. Now, the values in my first simplex tables are not going to change. The letters on top there are not going to change, meaning that I will still have my C. I will still have my C, which is my contribution. I will still have my basis. This is my basis. I will still have my X. I will still have my Y. I will still have my slack 1. I will have my slack 2. I will have my slack 3. I will have my value. And I will have my ratio. Now, the first thing you need to note as we transfer here, I want you to note this. A point where the key row and the key column intersect, it gives us a key element. And the slack variable in that row is called outgoing. Outgoing variable. Outgoing variable, we are going to replace that one with incoming variable. The incoming variable is going to replace outgoing variable. Now, I hope up to that point we are okay. Let me transfer my values in the next table. This is we're talking of second simplex table. Here, the slack variable S1 is still there. It is still there. S1 is still there. Then S2 has been replaced by X. S2 has been replaced by X. S3 is still there. S3 is still there. I still have my CJ. We said CJ is not going to change. CJ will remain 3000, 2000, 0, 0, 0, and 0. We said CJs are not going to change. Now, I still have my ZJ. I still have my ZJ, and I'll have my DJ. Now, the interesting part now comes in here. We need to transfer these values here, which has been replaced with X. And they have what we are calling the key element. We are going to divide all of them. We are going to divide all of them by the key. This is key element. So what is 4 divided by 4? 4 divided by 4 is going to give me 1. Take note, I'm dividing the values in the second row, which is the outgoing variable. I'm dividing this one with the key element, which is 4. And the key element is the point of intersection between the key column and the key row. This is 4. 2 divided by 4, it gives me 0.5. This one gives me 0.5. Then S1 here is 0. 0 divided by 4, it gives me 0. This one gives me 0. S2 here is 1. S2 is 1. Divided by 4, it gives me 0.25. S2 here, 0.25. S3 is 0. And the value, I'm transferring these values from the table here. The value is 50. 50, 180. So the values here, I'm going to bring them here. This is 50. This was 100, and this one is 80. And this one is 80. This is for this 80. This is 150. Let's do this. Here we need, let's leave the values this column first. We are going to fill this column as we move on. Let's first fill S1. Let's first fill S1. Let's first fill S1. Now, take note of this. Take note of, the contribution here, S1 remained to be 0. S1 remained to be 0. This is S1 remained to be 0. X, what is the coefficient of X? The coefficient of X here, the coefficient of X has been replaced and is found in our Z here. The coefficient of X here is 3000. So this one is 3000. And then this one is going to be 0. Now, there is a formula we are going to use so that we can find the values to bring in here as for S1. Now, to fill the column, we want to fill the row of X1. So, slash variable S1 row. This is what we are going to do for us to fill the values in slash variable S1 row. We are going to look at odd row values. We are going to look at odd row elements, odd rows element minus new row elements, odd row elements multiplied by balancing figure. Now, take note, I want to fill this row of S1. I'm saying I go to the odd row. Odd row S1 is 23100. That is 23100. Those were odd elements value. 23100. Now, minus new elements value. The new row I have here is the one which I brought the incoming X, which is 1, 0.50, 0.25. So here I have 1 I have 1 minus 0. It is 1, 0.5, 0.5 minus 1, 0.5 minus 0 minus 0 minus 0.25 minus 0.25 and the last one is 0 minus 0.25 and the last one is 0. Now I want to multiply this one by the balancing figure. What is this balancing figure? You go back to your initial simplex table, you look at the key column and the element that coincide with the row that we are looking at here. This row is our row of interest. The element that coincide with the key column, this one, is 2. So that 2 becomes our balancing figure. 2 becomes our balancing figure. Now, having identified this, we now need to work out. And how do we go about it? This is 2 minus 1 times 2. What is 2 minus 2? This is 0. Then 3 minus 0.5 times 2. What is 3 minus 2? 1. 1 minus 0 times 2. 1 minus 0, 1. 0 minus 0.25 times 2. What is 0.25 times 2? This will give us, this is minus. Remember, this is negative here. Negative 0.5. Then you have 0 minus 0 times 2. This gives me 0. So these elements are the new elements for the slack variable 1. So I'm going to bring them here. This one was supposed to be 2 because it's 3 minus 1 is supposed to be 2. So I'm going to have 0, then 2, 1, then negative 0.5, then 0, and that is it. Let's go to the slack variable S3 row. Let's go to S3 row. We are going to repeat the same process. Here we are going to talk of odd row elements minus new row elements times balancing figure. Let me go to the odd row. Odd row here, I'm having 53001. This is 53001. 53001. They are obtained from here. This is 53001. What about the new row elements? The new row elements are here. You're going to have 1 times 2. New row elements we have, they are on this new row here. That is 1, 0.50, 0.25 and 0. So 1, then we have here minus 0.5 minus 0 minus 0.25 minus 0. I've brought in the new elements. The new elements are not changing in the two instances. Here and this we are going to have the same. New elements. This one 1, 0.5, 0, 0.25 and 0. Now let's look at the balancing figure. The balancing figure for this this S3. We look at the initial simplex table and ask ourselves which value coincide the key column and the S3, the table we are looking at, or the row we want to fill. Which value coincide with the key column? In this case is 5. We bring our 5 here. So here we are going to multiply this one by 5. Multiply this one by 5, multiply by 5 times 5 times 5 times 5. So what do you get here? What is 1 times 5 minus this? This we get is 0. Here 0.5 times 5 is 2.5. 3 minus 2.5, you get 0.5. This is 0 because 0 times 5 is 0. Then here we have 0.25 times 5, that is 1.25. 1.25 negative, negative 1.25. And here we have 1. These are the values we are going to transfer to our new row, to our S3. S3 here, we are going to have 0. Then here we are going to have 0.5. Then here we are going to have 0. Then we are going to have negative 1.25. Then we are going to have 1. We are going to have 1 here. We are going to have 1. Now, having identified that, we come here and look for our Zj. How do we get our Zj? There is some computations that you require for you to get Zj. There are some computations that you require. I want to do Zj here. You are looking at Zj. This is what you do. The first value here, we are going to take 0 times 0, 3000 times 1, 3000 times 0. We add all of them. You find that Zj here is 3000. Then you take 0 times 2. 0 times 2 is 0. 3000 times 0.5, 1500. 0 times 0.5. When you add all of them, you find that this is 1500. You come to the same S1. 0 times 1, 0. 3000 times 0, 0. 3000, 0 times 0 is 0. So this one gives you 0. Come here. This is 0 times negative 0.5 is 0. 3000 times 0.25, that gives you 750. 0 times negative 1.25, the value you get here is 750. And finally, the value should come here is 0. I hope we are clear up to that point. Now, DJ, we say that if you want to get DJ, DJ, this one will be Cj minus Zj. Cj minus Zj. So when I subtract this, I get 0. I get this one is, when you subtract this one, you get 500. This one you get is 0, negative 750. And this one will be 0. This one will be 0. And this one has already been given from, if I pick 3000 times this, you get 150,000. Yeah, Zj. And then Then Cj minus this, it's going to give me negative 150,000. And the values here we have is 100, then here you have 50, and this is 150, and this is 0. Now, having identified these values, we need now to check optimality. Here I was helping you to know how to find a Zj. Like the first one, you said is 0 times 0 plus 3000 times 1, then 0 times 0 plus this, and we got 3000. So that's how you find the Zj. The Zj here, we are going to find that this is 0 times 0, 3000 times 1, 0 times 0, and then you find your values here. Now, let's now check optimality. Test optimality. Test optimality. Or just say optimal. Test whether it's optimal. For this to be optimal, it can only be optimal when the DJs are 0 or greater than 0. 0 or less than 0. If it is greater than 0, means it is not optimal. And here I have my 500. Now, since it's not optimal, I'm going to repeat the same procedure, but come up with another table which you're going to call simplex table 3. We come here and create that simplex table. That simplex table. I need to emphasize something. Let me emphasize something here. When I took, let me emphasize something here. That when we were looking for these values here, we divided this one by 4. You see here, these values here, we divided this one by 4 so that we obtain 50. I hope it's clear up that point. When I was filling the values for X row here, here we had the initial value for this row. Initial value for this row was 200. Then here we had 50 multiplied by 2. That's why I wrote 100 here. I want you to take note of that. The reason why I wrote this 100 here. When I was filling the value for S3, initially we had 400. Here we had 400. Then we had 50 multiplied by 2. Yeah. This was 50 multiplied by 5. 50 multiplied by 5, because here we're multiplying everything by 5. And then here we had 150. I wanted to emphasize on that. Now, I think up to that point, everyone is with me, that we have found that this table is not optimal. It's not optimal in the sense that DJ is greater than 0. So we are going to repeat the same procedure, come up with the third simplex table. Third simplex table. Let's come up with the third simplex table. Now, having understood how to come up with the second simplex table, here we are just going to work out the figures as we did in the previous table. Here we shall have our C basis, This is the contribution. We have our basis, then we have our x, then we have our y, then we have our S1, our S2, our S3, then we have our value, and finally we have our ratio. So we want to see how do we fill these values in this table. Our simplex table 3. How do we fill value here? Now let's move to our second table and look at the key column. Where we had the 500 here becomes our key column. This is our key column. We call this one our key column. This is our key column. Now, our key column on top here is going to give us our incoming variable. Take note of this. This one here is going to be our incoming variable. Now, so we come and look for our values here. And we divide them by, we divide our values with the coefficients in the key column. So what is 100 divided by 2? This is 50. What is 50 divided by 0.5? This is 100. What is 150 divided by 0.5? This is 300. And having identified this, then we are able to find our key row here. This is our key row. Our key row, where is going to intersect with our key column, we find what we call key element. Now, key elements and the key row is going to give us what we are calling outgoing. This is outgoing variable. This is outgoing variable. Outgoing variable. Now, we have identified our key column and the key row plus the key element. Let's fill our table now. How do we fill our table? We replace S1 with Y. So the basis here, we shall have Y, X, then S3. We have Y, S3, then CJ, ZJ. We have CJ, ZJ. This is Z, ZJ, and DJ. Now, what are the coefficients of Y? The coefficients of Y from the objective function, the coefficients of Y was 2000. The coefficient of X is 3000. Slack S3 is 0. Divide everything in row 1 with the key element. 0 divided by 2, 0. 0 divided by 2 is 0. Then 2 divided by 2, 1. 1 divided by 2, 0.5. So here I have 1, 0.5. Then S3 and S2 here, S2, 0.5 here. We have in 0.5 divided by 2, 0.25. This one is 0.25. Then we have S3, that is 0 divided by that, you get 0. 0 divided by that, we get 0. And finally, our value here was 100. 100 divided by 2, you get 50. I hope we are clear up that point. 100 divided by that, you get 50. Now, we need to fill the X row. How do we go about the X row? How do we go about the X row? I mentioned that you need to have the old row elements minus new row elements multiplied by balancing figure. I go back to the old row element. Here is 0.50. That is, I come and record them here. That is 0.50. Then 0.50. Then we have X 0.50. Then you have 0.250 and 50. 0.25. This is 0.250 and 50. 0.250 and 50. That is and 50 here. This one is and 50. I hope it's clear up that point. I'm only copying the old row elements. The old row elements are found in the second table. We are now in our third table. For X, 1, 0.50, 0.250 and 50. Here, 0.25 and 50. Now, having done that, I need to record new row elements. New row elements are on top here. Minus 0, minus 1, minus 0.5, then minus 0.25, minus 0.25, then minus 0.25, here, minus 0.25, this is minus 0.25, minus 0 and 50. This is 0, 0 and 50. I've just copied the new row elements. I've just copied the new row elements here. These are the new row elements here. These ones, 0, 1, 0.25, 0.2, 0.5, 0. All these are the new row elements. I brought them here. Now let's look at the balancing figure. We said for balancing figure, you look at where the key column meets the row in a consideration. Which row are we talking about? Here, balancing figure, we are replacing, this is row X. Yeah, row X. 500, where does it meet? It meets here. This is 0.5. Where 500 meets the row under consideration is 0.5. This becomes our balancing figure. So we shall have times 0.5. This is times 0.5 times 0.5 times 0.5 times 0.5 times 0.5 times 0.5. Can we have the new elements for this row? 1 minus 0.5 times 0. This gives you 0 and therefore is 1. 1 times this is 0.25, isn't it? 0.5 minus 0.25, you get 0.25. This is 0.5 times 0.5. This is negative 0.25. Let's come here. This is 0.25 minus, there is, let me use my calculator here. We have 0.25 times, look at this. Let me use my calculator and confirm the answer we are going to get here. Here we have 0. Let me pick something here. When you have 0.25 times 0.5, you get negative 0.125. Negative 0.125. Yeah? Negative 0.125. Then you minus the 2. So here we are going to have 0.5. We are going to have, this is 0.25 minus, this is 0.125. What do you get here? This is 0.25 times 0.25 times 0.5. Get this. Then we have 0.25. This is 0.125. This is 0.25 minus 0.125. You get 0.2. This is 0.2375. Then here we have 0. What do you have here? 50 times 0.5 is 25. 50 minus 25 is 25. I hope it's clear up to that point. Now, I can be able to transfer this to my new simplex table. We shall have 1, then 0.25, then negative 0.25, then here we have 0.235, 2375. This is 0.2375. S3, I have 0 and then 25. This is 0, then 25. Good. I'm now done with these two. I go to S3. S3, I'm going to do the same. S3 row. S3 row. I'm going to do the same. I need odd row elements. I come to table 2. I transfer what was given here as S3. This is 0, 0.50. I have 0, 0, 0.50. Then I have what else? 0, 0.50, negative 1.25, 0. This is negative 1.25, negative 1.25, negative 1.25, what else? Negative 1.25, then 1 and 1/5. 1 and 1/5. Good. 1 and 1/5. Minus, we need to utilize the new row elements, which you can easily get them from the previous working. Here we have 0, 1, 0.5, 0.25, 0, 50. We look at the balancing figure. What is the balancing figure here? The balancing figure is the point where the key column meet the row under consideration. The balancing figure here is 0.5. So I will multiply everything by 0.5. Multiply everything by 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. I hope you have seen where I've obtained my balancing figure. Now, work out this. What do you get? Here I will have 0. Here I will have 0. Here I will have negative 0.25. This one, if you multiply this one, negative 1.25, this is negative 1.25 minus this. When you multiply these two, what is 0.25 times 0.25? This is 0.25. 0.25 times 0.5. This is 0.125. So when you have 1.25, this is negative. Huh? So negative 1.25 minus 0.125. So minus 0.125. You get this one here. This one will be negative 1.375. Then this one will give you 1. And finally, this is 50 times 0.5. It is 25. 150 times 25. This gives you 125. Transfer this to your new. You transfer this to your new row. I'm having 0, 0, negative 0.25. Yeah. Then I have this is negative 0.25. Then I have negative 1.375. This is negative 1.375. Negative 1.375. And then I have 1 and 125. 1 and 125. Good. Now we have filled the 3 columns. We look for Cj. I mentioned that Cj is not changing. You have 3,000, 2,000, 0, 0, 0, and 0. Remember how we find Zj. How do we find Zj? It was 2,000 times this plus 3,000 times this plus this times this. Yeah. So what do you get? What is 2,000 times 0? That is 0. 3,000 times 1, 3,000. 0 times 0. So here I have 3,000. Here I have 3,000. I come to X. This is 2,000 times 1, 2,000. This column here was, yeah, this one was supposed to be 0 here. This one was meant to be 0, because if you take 2,000 times 1 is 2,000. 3,000 times this is supposed to be 0. This one is supposed to be 0 from here. This is supposed to be 0. Sorry for that. Supposed to be 0, and this is 2,000. Then here 2,000 times 0.5, 3,000 times negative 0. This 0 times 2,000 times 0.5 is 1,000. Yeah. Then you take 3,000 times negative 0.25. 0 times negative 0.25. Here you end up with 250. This is 250. This is 625. And then This is what? 625, then this is 0, and then this is 175,000. DJ, I said you take Cj minus Zj. So here I have 0, 0, negative 250, negative 625, 0, negative 175. Now, the reason why I did not look at the ratio here, in most instances, when you have this kind of inequality, you are only required to prepare up to the third simple table. So there was no need of me looking for the ratio because it was not necessary, as in I will not be able to get another table. So at this point, you notice that your DJs are 0 or less. So in this case, we can now get our conclusion. We can now get our conclusion. What is our conclusion here? Our conclusion, we look at the values here. We look at the values here. So for optimal solution, because already here we have the optimal, we can say this. For optimal solution, for optimal solution, you notice that the value of x here is 25, the values of y here is 50. So we can say that alcon, this one is x, which is 25 units. You have found the units 25 are on this one here, the final value here, x is 25. Y is xenon. Y is xenon. Xenon is y, and this one gives you 50 units. Maximum profit, the maximum profit is given as 175,000. The maximum profit is 175,000. Now, although it was not asked in this question, if they had asked you things like slack variables in this case, because x and y moved, then they are going to have 0 as their slank prices here. But 125, this one will be available because it had not changed. S3 remained where it was. And here these are shadow prices here. Anyway, that is not part of this question. This question wanted you, if you look at the question, they wanted you to formulate the linear programming model and get the solution solved. So ours in this question were to find the solution. And we have already found the solution where x is 25 units and y is 50 units and the maximum profit 175. They were obtained from our third simplex table. This is called third simplex table. Otherwise, that's how we use simplex method to solve linear programming problems. Goodbye for now.